Okay, to pick up where we left off, we were converting the density. Like I said, densities have to be converted step by step, one unit at a time, because we don't have the right conversion factors to do anything else with it than that. So here we've got, like I said, the densest element of all, osmium, which has a density of 22 grams per cubic centimeter, which probably doesn't mean that much to you. So I was proposing that we convert that to units that would be more relatable, like pounds per cubic foot. Okay, so that means we have to go from, in terms of units, we have to go from grams per cubic centimeter to pounds per foot. And in order to do each of these separately, we have to go from grams to pounds, and then we have to come back and go from cubic centimeters to cubic feet. Now for grams to pounds, let's look under mass, because that's what grams are. Technically, pounds are a weight rather than mass, but close enough. 1 pound, oh, there you go right there, first one. 1 pound equals 453.6 grams. Okay, that's going to be a useful one. And that actually does it. That's all we need for the first unit conversion. And then, let's see, to go from centimeters to feet. Again, you can use the same conversion factors that you would normally use for regular one-dimensional centimeters going to regular one-dimensional feet. Use the same conversion factors, but just cube the conversion factors too. And as long as you cube the numbers as you're multiplying it out, you'll be fine. So to go from centimeters to feet, that's length. So let's see if by any chance, oh, look, what do you know, right there. 1 foot equals 30.5 centimeters. So that's actually going to be easier than I thought. So we have 22.6 grams for every 1 cubic centimeter. If we're converting the grams first, which I would recommend doing because it's just easier to avoid forgetting things if you keep to an orderly progression, you know, like going left to right and top to bottom, for instance. Converting grams means that we're going to want grams in the denominator, and we have the conversion to pounds, so that's going to be pounds in the numerator. And the numbers tell us it's 1 pound for every 453.6 grams. So at this point, grams cancel, and if you wanted to write down the answer as an intermediate answer, you could do that. You get really weird units of pounds per cubic centimeter, which is not really something that you see very often because it's a mix of English and metric units. So let's keep going. Pounds are what we wanted in the numerator, and so that's done. Now for the cubic centimeters. We know that 1 linear foot, that is one single one-dimensional foot, is equal to 30.5 one-dimensional centimeters. So we're going to want centimeters on top and feet on the bottom. And it's 1 foot for every 30.5 centimeters. But remember, it's cubic centimeters. So we have to cube the conversion factor so that we basically have now cubic centimeters per cubic foot. And that means that cubic centimeters cancel. Remember, it's cubic centimeters were on the bottom in the original units. So that means they have to be on the top in the conversion factor so that they cancel out. And once they cancel out, we have feet left in the denominator. So we have pounds per cubic foot because the 3 is still there. It still applies to everything else inside the parentheses that hasn't canceled out. Okay, so it's going to be pounds per cubic foot. The number, again, you can ignore the ones as you multiply things out. The one thing you really have to remember, though, is that 3, the cube power, applies to the 30.5 also. And in fact, when I'm working out problems like that, sometimes I actually do what I just did. I circle the 3 and draw an arrow to the number so that I won't forget to cube it. So numerically, this would be 22.6 divided by 453.6 equals times, and then I would put the 30.5 in parentheses, 30.5 raised to the third power, close parentheses, just to avoid any misunderstandings, and then hit equals, and we get 1,413.6276. Should probably have a look at significant figures before we go off on any other tangents. 22.6 is obviously 3 significant figures. The 1 centimeter is assumed to be an exact number. Again, the 1 in 1 pound, per 453.6 grams, that would be considered an infinite because 1 pound is exact in that case. But the 453.6 is 4 significant figures. That is a conversion factor between English and metric units. So that means this number is rounded off, so you do have to count the significant figures. And 30.5 centimeters per foot, that is also a conversion between English and metric units. So you have to count the significant figures. And the 1 is infinite, but 30.5 only has 3 significant figures. So between that and the original number, we only get to use 3 significant figures. Let's see, that means we've got 1, 4, and 1 that can stay. The 3 and everything after it has to go. That means since the 3 is less than 5, that means the 1, 4, 1 can stay the same. But also notice that the 3 comes before the decimal point. So that means to maintain the right magnitude of the number, the 3 should be replaced with a 0. But don't write the decimal point, because if you do, then suddenly this number has 4 significant figures instead of 3. Because zeros at the end count if there's a decimal point. So just leave it as 1410, no decimal point, pounds per cubic foot. Now we can think about what that means. That means if you had a block of osmium that's 1 foot on each side, which isn't all that big, it would weigh 1,410 pounds. You probably wouldn't even be able to put it on the floor in your house because it would collapse the floor. I mean, that is 1,410 pounds is probably, let me see, it's probably about the weight of one of the old school Volkswagen Beetles, back when the engine was in the rear. They probably weighed about 1,400 pounds. So, and they weren't very big for cars, but we're talking about a block that's only 1 foot on each side. So that is a lot. It's like you compacted an entire Volkswagen Beetle into a block that's 1 foot on each side. And so, in other words, yes, osmium is really, really dense. Okay, let's see. That actually is probably the last of the topics I wanted to cover in unit conversions. And now I think I'll use the rest of this lecture in order to present some example problems to you where you can sort of get the setup of the problem, stop the video, try it yourself, and then see what you get. And then we'll, and then you can start the video again and I will go on to show you how to do it. Okay, so for example, we can try, well, for one thing, this is a relatively hard problem, so it might be worth trying an example yourself like this. So I'll set up something similar. We know that aluminum is one of the least dense metals. It's very light for its size. The density of aluminum is only 2.70 grams per cubic centimeter. And so why don't we try converting that to something that's relatable, like pounds per yard in this case. Pounds per cubic yard, that is. Okay, so pounds per cubic yard for aluminum. We'll see how that compares to a cubic foot of osmium. Okay, so you might want to pause the video now, give it a try, see if you can come up with a reasonable answer, and then we'll compare. Okay, so if you're back, first of all, we have to convert grams per cubic centimeter to pounds per cubic yard. For the grams to pounds, it's pretty easy. It's the same as we did before. 1 pound is 453.6 grams, so we can use that. For the centimeters to yards, let's see if there's anything in here for one-dimensional centimeters to one-dimensional yards. I'm guessing there probably isn't. No. There's centimeters to inches, and there's centimeters to feet. So we could use either one of those. How about centimeters to feet? Because, and hopefully everybody knows this, 1 yard is 3 feet. So if you can get from centimeters to inches, you can get the yards. So we're going to go for the top unit, we're going to go directly from grams to pounds. And the bottom unit, we can go from centimeters cubed to inches cubed to, what is it, yards cubed. Okay, so let's find out how we can do that. If we have 2.70 grams for every 1 cubic centimeter, as what we're starting out with, we want to convert the top unit first, so we want grams to become pounds. There's 1 pound for every 453.6 grams. Okay, there is, the grams have canceled, and actually we've got the top unit that we want. Now we have to go back and do the bottom unit, the cubic centimeters. Okay, that means centimeters have to be on top in the conversion factor in order to cancel out with centimeters on the bottom back here. And we know that 30.5 centimeters are equivalent to 1 foot. But remember, it's cubic centimeters, so this conversion factor has to be cubed. And I'm going to circle it so we don't forget. So now this is cubic centimeters here, and that will cancel with cubic centimeters over there. And then we can go from feet to yards. Feet are going to have to be on top, so they'll cancel with the feet on the bottom here. There are 3 feet for every 1 yard, but that's cubic feet. This is where it's especially important not to forget it. This is actually cubic feet, so we have to cube this conversion factor also. And I'm going to circle it again. Now feet cancel, and we have cubic yards on the bottom, which is what we want, pounds per cubic yard. If we multiply and divide this out, we get 2.70 divided by 453.6 times 30.5 raised to the 3rd power times 3 raised to the 3rd power. And we get 4,559.886161. That's a little more than I expected, but a cubic yard is a really large volume. So let me just check the math again to be sure that that's really what it should be. 2.70 divided by 453.6 is this times, okay, times 27 gives us, yep, that's it. Significant figures, we got 2.70 is 3. 1 pound for every 453.6 grams is 4. 30.5 is 3 again. And 3 feet over 1 yard, those are exact numbers because they're both within the English system. So that would be infinite. So 3 it is. And that means the 4 and the 5 can stay, but everything else has to go. Note that the first number you're dropping is a 9. That's greater than 5. So the last number we're keeping has to go up by 1. And also note that the 9 is before the decimal point. So we have to maintain the magnitude of the number by replacing it with a 0. But don't use the decimal point. Otherwise, that's 4 significant figures. So 44,560 pounds per cubic yard. So even for aluminum, which isn't very heavy, the mass can really add up if you have a lot of it. 4,560 pounds is equivalent to probably one of the large SUVs that you see on the road. I'm not even up on them now. Chevy Suburban, if that's still even being made, or the Ford Expedition, or maybe one of the fancier decked out Explorers. They're pretty heavy, so they might be in that range. Okay, so in this vein, hopefully you got that answer. If not, then you can rewind and sort of review what we did and try to figure out where you went wrong. There are many other examples that we can go over, so we'll try a few more. Let's see. Let's see, a bit of trivial interest here might be that the largest passenger car engine used in any mass-produced car anyway since World War II was used in certain Cadillacs in the early 1970s. And the way the size of an engine is conveyed is usually through the piston displacement. I think I mentioned before, that's the volume that's swept out by the pistons as they move up and down in the engine. When you add all of that volume up for all 8 pistons in this case, the total volume we get is called the displacement of the engine. Okay, and so that would be 500 cubic inches. That's a really big engine. There were ones even bigger than that before World War II, but let's keep it within reason here. 500 cubic inches. In internationally, and also now in the United States more recently, it's quite common also to convey engine displacements in units of liters. So I was just wondering, if it's 500 cubic inches, what is that in liters? And so this is a challenging question because we're talking about volumes here. Length units to the third power, that's a unit of volume. And liters, that is obviously a unit of volume. And so we just need to figure out how to convert from one to the other. The first thing you might want to do is look in the conversion factor sheet under volumes to see if there's something that would allow you to do it in one step. So we have 1 liter quarts. Oh, well, look, we have 1 cubic inch in cubic centimeters. That might help. So I think that's the one we need to use. Because if we can go from cubic inches to cubic centimeters, we can just remember that cubic centimeters are the same thing as milliliters, and then we can go to liters. Okay, so that's really important to remember, that 1 cubic centimeter is the same as 1 milliliter. Otherwise, you might have a really hard time doing this question. Okay, so 500 cubic inches. To go to centimeters, and we look for a conversion factor. Actually, we have the conversion factor between cubic inches and cubic centimeters, so we don't have to worry about cubing the conversion factor. The numbers here are already cubed. So in the conversion factor, we want cubic inches on the bottom and cubic centimeters on top, so that cubic inches will cancel. And it's 16.39 cubic centimeters for every 1 cubic inch. Cubic inches will cancel, and we've now achieved cubic centimeters as the unit. As I mentioned before, and as hopefully you'll remember, 1 cubic centimeter is the same as 1 milliliter. To make that official in the equation, you can write a conversion factor, which just takes the form of the relationship between milliliters and cubic centimeters. Make sure cubic centimeters is on the bottom, though, so that it cancels out with cubic centimeters on the top. And the number is just, of course, 1 to 1, because they're the same thing. So cubic centimeters cancel with cubic centimeters. We now have the volume in milliliters. And going to liters is just a matter of knowing what the prefix milli means. It means, where is it? 1/1000th, or 10 to the minus 3, or 0.001, because I don't like putting exponents in the calculator if I don't have to. Let's see, milliliters are on top. So we want 1 milliliter on the bottom to cancel, and 0.001 liters on top. Milliliters will cancel, and we should have liters when we multiply everything out. Okay, so 500 point, that's going to be important later, times 16.39. Now remember, we had a conversion factor directly between cubic centimeters and cubic inches already. So those numbers were already cubed. In this case, you put the 3's inside the parentheses, because if you put the 3 outside the parentheses, that means that everything inside the parentheses needs to be cubed as you're multiplying things out. These numbers have already been cubed because it's listed in the table as cubic centimeters and cubic inches, in the table. So don't write the 3 outside the parentheses. You write them inside the parentheses. So it's 500 times 16.39 times 1 times 0.001. And we get 8.195 liters. Let's see, significant figures now. That's not a huge number of significant figures, but it still might be too many. 500 point, that's 3 significant figures. 16.39 is 4 significant figures. This is infinite because those are exactly the same thing. So that's 1.00 on to infinity, and same on the bottom. This is a conversion factor within the metric system, so that is also considered infinite. And so 3 is the limit. All right, this gets interesting, because that means 8 and the 1 and the 9 are all significant, but the 5 has to go. But the rule is that if the number you're dropping is 5 or greater, then the number before it has to go up by 1. Well, the number before it is 9, so if that goes up to 1, that's basically 10, and you carry the 1, and so it becomes 8.20. So that would be the correct answer to the correct number of significant figures, 8.20. And that's right, it was an 8.2 liter engine. Compare that to some of the ads you see for cars today, where you'll see most cars are maybe in the range of 2 or 3 liters, maybe 4 if you got something fairly big, and that was 8.2. That was huge. Okay, well, that's 26 minutes, so we're actually a little over for this segment. My apologies. We'll probably do a few more unit conversions next time. We still have to talk about the scientific method, and if that doesn't take up the entirety of the next lecture, then we will finally maybe get to chapter 2. Okay, so hope you're working along on the homework, and I'll see you next time. Okay, bye.